move ahead to the next topic of spherical mirrors. I already told you spherical mirrors can be classified into two, concave and convex. Concave mirror. The spherical mirror whose reflecting surface is curved inwards is called as concave mirror. Children, see here, this is going to be the reflecting side. And for convex, the spherical mirror whose reflecting surface is curved outwards is called convex mirrors. I hope I am clear. We will move ahead with the concave mirror first. We have some definitions to look into it. So, we will go ahead with the definitions. It is already there in the textbook. You need to mark and learn all the definitions before you go ahead with the ray diagrams. Definitions for concave mirror. This is the concave mirror. Immediately when you draw the mirror, just put the dashes, and the imaginary line which passes through the center of the concave mirror is called the principal axis. It's called the principal axis. The center of the reflecting surface of a spherical mirror. This is the spherical mirror. The center of the reflecting surface of the spherical mirror is called a pole, and it is represented by the alphabet P. I have taught you two things. Number one, pole. Number two, principal axis. Number three, I'll go ahead with another topic called the center of curvature. The center of curvature is, children, just imagine this to be a sphere. Suppose, imagine this to be a whole sphere, and I am going to take a part of the sphere. I am going to cut this and take it out. When I cut this part of the mirror will have a center. So, center of curvature may be defined as the center of the sphere of which the mirror is going to be a part. I repeat, center of curvature may be defined as the center of the sphere of which this mirror is a part. Center of curvature is represented by the alphabet C. It's represented by the alphabet C. Similarly, you can define radius of curvature. Radius of curvature is the radius of the sphere of which the mirror is going to be a part, and radius of curvature is represented by the alphabet R. Moving ahead to an important definition called the principal focus. You can define principal focus both the ways. It is different for a concave and it's different for a convex. Concave mirrors are also called as converging mirrors. Converging mirrors. I'll tell you why. Now, I'm going to consider an object here. An object which is kept at infinity. Consider two rays moving parallel to the principal axis. Children, I am drawing two rays that is parallel to the principal axis. One above the principal axis and one below the principal axis. It goes like this. Ray of light moving parallel to the principal axis. It goes, hits the concave mirror and gets reflected. It gets reflected and comes back like this. This is for this incident ray. For this incident ray, it goes, hits the mirror, get reflected this way. They both meet at this point, and that point is termed as focus. I repeat, ray of light moving parallel to the principal axis. After hitting the mirror, they get reflected and they meet at a point on the principal axis, and that point is termed as focus. Children, why do we call concave mirror as converging mirrors? Look at the reflected ray. How does it come? Look, both the reflected rays, they converge at a point. These two reflected rays, they converge at a point. So, concave mirrors are also called as converging mirrors. So concave mirrors are also called as converging mirrors. Understood? You need to learn all these definitions from the textbook. Then you have 6 ray diagrams to be learnt for concave mirror. We have 6 ray diagrams to be learnt for concave mirror. Before going into the ray diagram, I will tell you there are some rules to be followed to draw the ray diagram. There are some rules to be followed to draw the ray diagram. I will tell you one by one. I am going to talk only about concave mirror now. Rules to be followed to draw a ray diagram for a concave mirror. First rule, this is going to be our principal axis. This is our pole, focus, center of curvature. When you draw the ray diagram, make sure you take 2 cm in between. P and F will be 2, F and C will be 2 cm. Children, this is going to be the object. I am placing the object on the principal axis. The first rule, ray of light moving parallel to the principal axis, it has to pass through focus. The reflected ray has to pass through focus. That's going to be our first rule. I repeat, rays of light moving parallel to the principal axis. This is the principal axis. When it is going to go parallel to the principal axis, the reflected ray has to pass through a point on the principal axis, and that point is called as focus, so it passes through focus. If it's going to be parallel, it has to pass through focus. Second ray, I will draw all the 3 in the same, I will sketch all the 3 in the same diagram, children. So second ray, if it is going to go through focus, if the incident ray passes through focus, look at this, always draw the ray from the tip of the object. I am going to draw it from here. If it goes through F, it has to render, the reflected ray has to render parallel to the principal axis. If it goes through F, it has to go parallel to the principal axis. This is going to be my second rule. Third rule, if it is going to pass through C, children listen, this is my incident ray passing through C. It goes, hits the mirror and it retraces its path. It comes back through the same path. This is going to be for the third ray diagram. The fourth ray diagram, the rule, a ray incident obliquely to the principal axis is reflected obliquely. Suppose I have an oblique incidence like this, one second. I have an oblique incidence like this. Suppose it is going to get incident obliquely. It has to get reflected obliquely. That means angle I should be equal to angle R. That's going to be our fourth rule. Fine. So, in short, rays of light moving parallel to principal axis has to pass through focus. If it is going to pass through focus, it has to go parallel to the principal axis. And if it is going to pass through C, it has to get back through C. And the fourth rule is ray of light incident obliquely to the principal axis. The reflected ray will also get reflected obliquely and it will follow the laws of reflection. We have 6 ray diagrams to draw, and before I could go to the ray diagrams, you have a tabular column in page number 164. Page 164 you have the tabular column. You need to learn the tabular column so that it will be easy for you when you go ahead with the ray diagram. We'll stop with this, children. I'll come back to you with the next topic in the next session. Thank you.